All right, last time we started section 8.5, and 8.5 was titled Equations in the Cartesian Coordinate System. We had talked a little bit about graphing and about the XY plane, and we are at the point where we're going to be talking about systems of linear equations. So a system of linear equation is a set of equations, usually with more than one variable in each equation. So you usually end up with something that has x and y in it, and you're somehow comparing these two equations together. You're comparing them usually to find out what their solution is. So the solution is the place where they intersect one another, where they cross. And sometimes they don't cross. So what do we call those when they don't cross? Parallel, right? And sometimes they cross in a very, very specific way. Do you remember what that one's called? Like intersect in a specific way. What did you? Perpendicular, right? They intersect at those right angles, kind of like we were talking about in the last section. All right, so this one's talking about the solution in general. So the solution to a system of linear equations is an ordered pair that belongs to both lines. It's the place where they intersect. So that is, we need to find the xy common to both, satisfies the equations graphically. This is the point of intersection. I've said it 3 times, I think, at this point now, right? It's the place of intersection. So what we're going to be doing next is we're going to be doing a couple of different methods for finding those places of intersection, okay? And I know you've seen both of these before. Neither one of them are useful in every situation, but they both have very good uses when they are used. So the first one is called the substitution method. These are the steps. Basically what you do is you solve one equation for one of the variables. So like you get one equation to say x equals something or y equals something. And then you use that value to plug it into the other equation and solve. You end up getting some solution like x equals 5, and then you use that number to plug it back into the other equation and to finish solving for the other variable. It's a good idea to check the solution at least mentally, make sure that it really works, and then to write the solution as an ordered pair, or in terms of a context problem, some kind of a value with units, right? So if you're talking about the length and width of something, maybe you have 5 feet by 3 feet or something like that. So we're going to do one with some context. So this is going to be a substitution method problem. It says at a movie theater, a child's ticket costs $5 and an adult ticket costs $8. On Memorial Day, the theater counted 562 audience members and a total of $3,785 in ticket sales. How many child tickets and how many adult tickets were sold? So there's 2 things we're looking for, and those 2 things are going to be our variables in this problem. So let's actually identify what we're going to use for which one of them. So again, normally we use x and y. You don't have to, but it's sort of the typical. What would you like x to be in this problem? Child? Okay, so this would be the number of child tickets, right? Or you could say the number of children who came. Either way. So then the other variable, sort of just by convention, is usually y. What would y be? Yeah, the number of adult tickets. Okay, so there's 2 equations we're going to be able to set up with this information. One equation has to do with the money, right? There's some money discussion. The other equation has to do with how many people actually showed up. So can somebody give me one of the equations that you see that we can set up here?
X plus y equals 562.
Okay, does everybody see where Amy got that one? X plus y equals 562. Looks okay? All right. What would the other equation be?
5x plus 8y equals 3,785.
Okay, so 5x is because we have x number of child tickets, they're $5 each. 8y, y numbers of adult tickets times the $8 each. And the total amount that we're going to get by doing this is 3,785. Is everybody good with the equations that were created? Okay, so again, the substitution method's idea is to take one of these equations, and you get a pick, and to solve it for one of the variables, and you get a pick. And so there's usually one of the equations or one of the variables in one of the equations that's a natural choice. So what would you like to solve, which equation, and for which variable? Skylar?
Probably the second one and do it by the 5x just because it ends in 5.
You could do the second equation by 5x. I think there's an easier choice.
The other one with x equals 562 plus y.
So why do you like that one, Elena, to do?
It just has a lot fewer steps, and it creates y, so I only have one more variable.
Yeah, so see, Skylar, you're right. Dividing by 5 on the right-hand side of the second equation would be nice, but you're also going to have to divide that 8 by 5, which means you're going to have a fraction or a decimal in the middle of the problem, which is going to be messier to work with. It's doable. You can definitely do that. But the first equation, I don't have any decimals or fractions to deal with, which makes it a little bit cleaner. So, and then in the first equation as well, there's absolutely no indication of which one would be better, right? I mean, if I solve for x or y, it's going to be equivalent. I'll just solve for x since it's listed first. So that means x is going to be equal to 562 minus y. Okay, is that good so far? All right, and then the idea is to take this value and to plug it into the variable x in the other equation. So I can take 5, which is already there. I can plug into x the value that x is equal to, which is 562 minus y. And then I have the rest of the equation as is. Plus 8y equals 3,785. One equation, one unknown, which means I will be able to find y equals. So somebody tell me, what do I need to do? Yeah, distribute. So what's 5 times 5,680, 562?
2,810.
And then the other distribution is just going to be negative 5y, right? Plus 8y equals 3,785. Now what?
You're going to do your whole number to be, or you can combine your y's first.
We can. So we could write 2810 plus 3y, right? Equals 3,785. All right, now what?
You're going to subtract 2,810 from 3,785.
Okay, so what does that give me?
It gives you 975.
Is that good with everyone? 975? And then our last step would be the division, right? Divide by 3. Okay, so what's 975 divided by 3? 325. Okay, that's x. I'm sorry, y, excuse me. I need to find x as well. What's the easiest way to find x? Yeah, plug it in that equation that we had that said 562 minus x, right? I'm sorry, 562 minus y for x. So this would be 562 minus 325. And what would that equal? 237. Okay, it is important to realize, let me point out that I could actually plug that number for x anywhere I wanted to, right? I mean, sorry, the y. What did I have? Y. That number for y, this 325, I could plug it into any of these equations that have x and y both in them, and the answer will result in the same thing. So it doesn't hurt if you chose a different one to plug it in. You'll get the same answer. There's 2 more steps that we haven't done yet. What are they? To check your answer, make sure it works. So one of the check steps would be to make sure that both of these add together to be 562. Do they? Excellent. What would the other check step be? Yeah, the money equation, right? Let's make sure that when I put in these values for the number of child tickets and adult tickets, I really get the correct total amount of money that was taken in the box office. So does it work? Excellent. So we did the check step. We don't necessarily have to write that down, but we do check it sort of mentally or in our calculator. And then what's the other step we need to do? Or, what did it say? Ordered pair or with units. And this one's one we're going to do it with units because it makes sense, right? This one had context. So what is 325? What is 237?
237 child's tickets were sold.
So this is the number of child tickets sold for the 237. And the 325 is
The number of adult tickets.
the adult tickets that were sold. And that's our final step. Any questions on the substitution method? Okay, let's look at the elimination method then. The elimination method is the idea of being able to take two equations and add them together, but when you add them together, something disappears. Either the x disappears or the y disappears. So these are the actual steps. If it's necessary, you will multiply both sides of each equation by a suitable number. Okay, so suitable means something that's going to make something disappear later. I mean, that's the idea. So that when you add the equations together, the variable, whichever one of them, is eliminated. You're going to add the equations together and eliminate such variable. And you'll solve the remaining equation just like we solved the remaining equation here. You'll back substitute to find the other value. And then steps 4 and 5 are the same as the last time. We're going to check to make sure the solution makes sense, that it works, and then write the solution either as an ordered pair or with units. Okay? So, we do an example with food, because I know you guys aren't at all hungry, right? It's not that time of the day. All right, at a bake sale, Cassandra sells 4 muffins and 6 cookies for a total of $18. Michelle sells 3 muffins and 11 cookies for a total of $20. How much does a muffin cost? How much does a cookie cost? What are we going to let our variables be? Let's start with that.
M and C.
Okay, M is going to be what? Okay, it's not muffins exactly. What is it?
Muffins. Coffee.
It's the cost of a muffin, right? I don't want you to get confused and think it's a number of muffins, because that's not the case, right? It's the cost of a muffin that we're trying to find out here. Okay, so if we used M, what's the other one we're going to use? C, which would be the cost of a cookie. Okay, so now we need to figure out how to write these equations so that they work. So in the last example, we had, an equation set up about cost and an equation set up about numbers of tickets sold. This one doesn't work quite like that, right? This one, we're creating 2 equations based on each individual girl's sales. So let's talk about Cassandra first. What would hers look like?
4M plus 6C equals 18.
Okay, so 4M is because she sold 4 muffins. So 4 times the cost of a muffin would tell me how much money she made from muffins. And then 6 times the cost of the cookies, because she sold 6 cookies, would be the cost of her cookies, and that's a total of 18. All right, so what would Michelle's look like using the same idea?
30 plus 11C equals 20.
Excellent. All right, so our goal is to take these 2 equations and to somehow get the same number in front of M, but different signs, or the same number in front of C, or different signs. And you really have choices, right? First, you got to decide, do you want to use the M or the C? And then you've got to decide what numbers you're going to use to actually make that happen. So let's decide together. Do you want to get rid of M or C? M. Okay. So if I get rid of M, how is that going to have to happen? Yeah, so what would I multiply the first one by, Jacqueline? What do you think?
You could multiply the top one by 3 and then the second one by 4, but one of them would have to be negative.
Yeah, it's important to realize we definitely need to make sure one of them is negative. And we can pick which one we want to be negative, so which one do you want? The first one. All right, let's go with it. All right, so let's take the next step then to rewrite these all multiplied out. So we have the first equation. What will it look like? Negative 12M equals, and somebody's going to have to do a calculator for 3 times. 54? Negative, right?
Negative, yeah.
Negative 54, fantastic. All right, we're going to do the same thing on the second equation. What do you get for the second one?
12m plus 44c equals 80.
I think the multiplication was easier on that one, just a little bit. Okay, so again, the whole goal was to get one of the variables to have the same number in front of them, but opposite signs, and we did that. So now we can add, like we would add with like whole numbers, right? You can add straight down. So when you add 12m and negative 12m together, you get 0. It doesn't give you anything. But the c is the will. So you get negative 18c and positive 44c. What does that give me? 26c. And how about negative 54 and positive 80? 26. That was nice, wasn't it? Okay, and then what we're going to do? Yeah, divide by 26. So we can find out that the cost of a cookie is 1. All right, we'll use the units in a minute, but it's $1, yeah? How am I going to find the cost of a muffin now?
You choose one of the equations and plug in what you have received.
Great, and I have 4 equations on the board, right? I can pick any one of them that I want. Probably the original ones are a little bit easier to work with because the numbers are smaller, right? So let's just take the very first one that we created, Cassandra's, okay? So we're going to take and write down 4m plus 6 times 1, obviously that's 6, equals 18. What will we do next? Minus the 6, right? Because 6 times 1 is 6, sure. So I have 4m equals what? 12. And then what?
You divide by 4 and get m by itself.
Right. So what will m be?
$3.
M is 3. All right, so let's check and make sure it actually works. And in order to do that, we're going to have to think through the problems themselves. So this would be 4 times 3, which is 12 plus 6, because c is 1. So is 12 plus 6 18?
Yes.
Yeah, and we were most likely to have gotten that one right because we used that equation to find it, the c value, the m value, right? Okay, let's check with the second one though. This would be 3 times 3, which gives me 9 plus 11. What is 9 plus 11? 20. Fantastic, so we got the right value. The last thing then is to simply write it out with units, because this problem has units. So what in the world did I find out?
Cookies equal $1.
Right, the cookies cost $1, and the muffins cost what? $3. You got it. All right, any questions on that? All right, so most of the time when we actually go through these problems, we get one solution. That's very typical with equations. However, there are other things that can happen. So a system of equations could have one solution. Graphically, that means they intersect in one place. Obviously, they can't intersect in 2, right? Lines are straight. A system could have no solutions. So what would that look like if it had no solutions? That would be my parallel lines, okay? So this is what I have going on here, okay? The first one, they intersect, such and such. A system could have infinitely many solutions. They would be the same line. You guys remember this stuff. Fabulous. Yep, same line. Here we go. All right, so we're going to take a time out real quick. I want you guys to solve a couple of systems. These do not have context. So how will the end of these problems be different than the end of our problems? We'll write them as an ordered pair. You'll write the x value first, the y value second. So take a couple minutes, and I want you to solve these 2 equations. Once you're done solving, I want you to check with the neighbor, make sure you got the same thing, and then we will come back together and make sure everyone has the correct solutions. Okay, turn to a neighbor real quick. Check what you have with what they have. I know some of you already did that, but if you didn't already,
I wasn't figuring,
I kept getting
well, I was getting like a zero, whatever variable equals something, so.
She did this too.
I know, I tried it like 2 ways, I was like,
What'd you get for whenever you did the problem?
Yeah, I think that's
When I did the problem the other way, I got x equals 8 and then y equals 7. So depending on which way you did it, you got different answers.
you shouldn't.
You shouldn't?
No, you should always get the same answer no matter which way you do it.
Okay, because I got.
There's probably an error somewhere.
That's what I'll do. I got no solution. Yeah, I got no solution.
That means yes.
All right, what happened on the first one? What answer did you guys get?
4, 3.
4-3 is correct. If you did, Elena was saying she did it one way and got one answer, another way got another answer. It means one of your problems is incorrect, right? And you can check and see which one's incorrect by simply checking both the solutions you found, right? So if you plug in 4 and 3 and it works, then that's the correct one. You've got an error in your other work, okay? What happened on number 2? I mean, I don't want to know the answer, but what happened somewhere along the way?
We were getting like 0 for one of the variables, and it wasn't, I was getting like 0 y.
Okay, so you got a 0 coefficient on a variable. So like the variable went away,
Yeah.
right? And so
Those two numbers
so
on either side.
both variables went away, right? And the two numbers on both sides were not equal, correct? They were not equal. So you ended up with, I heard you guys saying what the numbers were you guys ended up with. What did you end up on both sides? Did you guys do elimination? I thought I heard somebody. We did substitution. What are the numbers you ended up with?
-2 equals 3.
Okay, so you may not have ended up with these numbers, but I just want to give you an example of what happens. So when you end up with two numbers that are not equal, then that means there's no solution. Okay, so there is no solution here, which means that these lines are what? They're parallel lines. You don't have to necessarily write that down right now because it didn't ask that, but that is what happens here, right? No solution. If you had gotten an answer where it said something like this, okay, this is not this problem, but if you'd gotten that, what would that mean? That would be infinitely many solutions. They're the same line, okay? Just reminding you how that works. Okay, very good.